Okay, so we're kind of turning the chapter a little bit and we're starting to think about design at this point. Um, the one thing that I would say that you guys are missing in your project milestones would be the modeling of the thing side, or the ERDs. Once we do that, which you guys will be working on Thursday, the next thing is where we do a short presentation and you share where you feel the current system is, and that point of doing that short presentation is kind of the inflection point to start to move into design a little bit. Again, it doesn't mean that we're done with analysis, because as you recall, we're doing this kind of iterative process where you're going to cycle back through a lot of these same things that you've been working on and refine them based on the type of feedback that you get from your clients. And you're definitely going to be getting some feedback from me post presentation, perhaps even during the presentation. But again, there's one last thing you got to do, which is the ERD. So after that, we'll hit that inflection point and we'll start thinking about some of this stuff, some of this design stuff. So what is the kind of the main distinction between these two phases? When you're doing analysis, you're thinking about, as the slide here says, what is required. You're doing your requirements gathering. You're doing your breakdown of those requirements into cohesive units, which we tend to think of those as use cases. You think about your initial modeling of what the data is and what the process is. Once you've determined that and you feel pretty strong that this is accurately representing the type of system you want to build, then you move into the how phase. And in the how phase, it's okay, how are we going to build this? This is what it was, analysis what it was, and now design is going to be, okay, how does it work? We did initially cover the analysis in chapters 2 through 5. And then this one, kind of like chapter 1, I don't know if you guys remember since it was a while ago, but chapter 1 kind of gave the whole process all the way through at a superficial, not a very deep level. And that's kind of what we're doing a little bit here with this chapter. This is kind of introducing design as a whole at not a deep level. And you're going to start to consider this gap between what the system, describing the system and actually building the system. And this goes in between those things. This links those two things together. So analysis provides the starting point, of course, and the design itself, this is, again, when you start to think very specifically about implementation. The main problem with implementation, interestingly enough, is the limitations and the boundaries set forward by technology. Because I know a lot of you guys, I think almost probably all of you have coded in Python. Some of you a little bit of Java. But what if you were given a situation where it's with a language that you weren't necessarily comfortable with? What if it was, say, C++, and you haven't really programmed in C++ yet? In that case, you would get stuck in some of the really basic things, and you don't want to be worrying about your logic as you're also worrying about the syntax. So with a design, it allows you to, without the restrictions of the logic, without the restrictions of the technology, you can now focus on just the logic alone and think about how the system should be built. It allows you to define, organize, and structure the components of the final solution to serve as a blueprint for construction. So there are various objectives that you have with this whole process. The main thing with analysis, as we said, is the what. So this is understanding and specifying what the new system will accomplish. Now, let me add a caveat to that. It's not just what the new system will accomplish, it also requires that you have a firm understanding of what the current system does. And as a matter of fact, for your presentation, that's one of the two main components, is describing the current system. So, actually, hold on, it looks like I have no, I don't have a comment. This is always so weird in online classes. Normally, in a face-to-face class, I'd throw a question out right now, and I would ask, why is it important to understand the current system? And I suppose I could throw that out to you. Maybe you could type in the chat. But there is certainly a reason why it's important to understand the current system, even though you're not building it. I mean, the current system's already there. I don't know if anyone's typing, but if you're not understanding the current system, allows you to more thoroughly design the new system with a deeper understanding. You have to understand that there are flaws in the current system. You have to understand that there are improvement possibilities in the current system. And there are different degrees of that. For example, with BPA, business process automation, which is the most basic form of transitioning from an old system to a new system, you're simply automating existing processes. You're not changing anything. All the way up to business process reengineering, which is we're completely changing the way everything is done. You can't do that without currently or understanding the current system. Your deliverables for the analysis is going to be the models and documents, like the use case diagrams, the entity relationship diagrams, the use cases themselves, the fully developed use cases. This is what comes out of your analysis phase. And then that's going to feed into your design, where again, you're going to describe how the new system will work. At this point, you're not really concerned about the old system anymore, because it's not something that you're worried about creating. You're worried about creating the new system. So based on the incoming data from the analysis phase, you're now going to plan out specifically how the new system will be built. The deliverables from that, as you see over here, the design models and documents, these could be structure charts, program flow charts, data flow diagrams, fully attributed entity relationship diagrams. All of these things that will be coming out will directly inform your developers who work down here in the implementation exactly how they're going to build the system. Now, this chart doesn't really describe the people involved, like the main players involved, but your developers are only minimally involved in analysis and design. This is primarily a systems analyst would be the person that is mostly working on these things. They may touch base with developers, but more in terms of technological clarification more than anything, not for creating any of these deliverables. When you move down here, though, it's primarily the developers that are going to be working on this. And they're going to be pinging back to the systems analyst to maybe for clarification or for further understanding. Something may not make any sense. I'm not familiar with the curriculum at CNU, like I guess it's the CPSC 150 class where you may have done some programming. But I would hope that some documentation was required. Assuming there was some documentation required, you may recall running into situations where you felt like you planned it out well enough, and then when you went to build it, you realized you didn't even consider some really important aspects that didn't come up until it was actually coding time. And this is where you're going to have that iterative loop, where you're going to go back to you being the developer, would go back to the systems analyst and say, hey, you might want to check with the users. I don't think this is right. Do you consider the developer's job or the analyst's to be more important? Greg, if you asked me that on a test, I would say that's a trick question because I don't know if I can really quantify a ranking for analyst versus developer. It's kind of like asking, in terms of building a house, who is more important? Is it the person that lays the foundation or the person that does the plumbing and the wiring? I mean, they all kind of have to work, right? Now, does the plumbing and the wiring matter if you have a bad foundation, or does that become kind of central? So my point of getting to, you could almost make an argument that in this analogy, the systems analysts are laying the foundation. They're the ones that are saying what the system should be doing. When it comes to the nitty gritty details, the developer is kind of like the plumber, the electrician, the framer, the drywaller. You know, that they're actually building the house itself, but they're building it on top of a foundation. But if I only have a foundation, what's the point? I have to have the house as well. So that's where you could make the case that the developer is as important, but in their own way. I hope that explains it. Let me see. I think there may have been a follow-up. Which gets paid more? The systems analyst. Systems analysts average, I guess I see where you're going with this. So I guess maybe you're asking, could you infer that more money equals more importance? I think that's maybe where you're going with your question. And I would say that systems analysts will generally earn about twice what a developer will earn. I would average around 140,000 would be a typical systems analyst salary, and a typical developer salary, say with less than 10 years experience, maybe less than 7 years experience, typical developer salary on the East Coast would be around 70-ish, 65 to 80, depending on what company you go with. Whereas systems analysts, you would start over 100, and with 3 to 5 years, you'd be at 140 or so. Again, these are East Coast pricing models. You earn substantially more on the West Coast. Systems analysts on the West Coast are around 250 to 350, and standard developers are about, it depends, again, hugely dependent on which company you go to and what type of coding you're doing and what your expertise are, but probably 150 to 200 on the West Coast. Of course, a 600 square foot house costs, I don't know, 1.5 million. So the cost of living outweighs that. All right. Yeah. Okay. So let's continue on with this discussion on design. As you did in analysis, you will be building more models. There is a lot of value to models. There's the old saying that a picture is worth 1,000 words. And when it comes to communicating your blueprint to developers, this model is going to be extremely valuable to them for a quick understanding of what exactly they need to do. Different organizations have different, I almost call them social norms, but I guess they're more organizational norms when it comes to what types of models you use, how complicated they are, how in depth they go. And I would say the correlation of size of the organization with complexity is very, very high. There's a very high correlation there, where the smaller the organization, the less formal you'll be, and the larger the organization, the more formal you'll be. And there are exceptions to that rule. One great example, almost infamous example, would be Google. If you guys ever go work for Google, you'll see, although they are a very large organization, they tend to have less formal approaches than other large companies. Another thing to consider is methodology. We talked, I think, second or third week about the different methodological approaches, and the agile iterative approach, because you're moving through at a quicker pace and your main focus is on the actual code output, you tend to have fewer models than, say, a traditional waterfall approach or even a spiral approach. You're probably going to have more models than that. Um, I will say that developers really, really hate documentation. They hate design. Now, if they're not doing it, they're okay with it, because then it puts the kind of the responsibility on the systems analysts, and the systems analysts, that's their job, is to create these. And if a developer's given them, they're going to be happy that they're not guessing what the requirements are, that it's going to be nice and clear for them. But I will say that because of the cost, Greg had asked earlier about how much do a systems analyst get paid? Because to an organization they cost a lot, oftentimes they like to skip that step and just use developers for the whole process. And when you just use developers for the whole process, they tend to either very quickly go through or completely skip the real analysis and design phase, and they just sit down and start trying to hack out a solution with the code. And as the textbook says, totally agree with this. This is 100% true. You will have less than optimum solutions, and to the point of very high likelihood of failure. This isn't a perfect transition, because we're doing things a little bit different than the textbook's suggesting, particularly when it comes to domain modeling. But it's interesting to consider nonetheless. For example, the domain model class diagram, it shows that feeding into a design class diagram. The best description I can give is that we're doing entity relationship diagrams in place of domain model class diagrams. There are things called, which we'll talk about, fully attributed entity relationship diagrams. And the difference between a fully attributed entity relationship diagram and your standard entity relationship diagram is structurally almost non-existent. It's quite small. But in terms of the core information, it's quite a bit more. So what I mean by structurally is, say you have 5 main entities that are connected in a certain way. In your standard entity relationship diagram, it's going to look exactly the same as your fully attributed entity relationship diagram. However, in the entity relationship diagram, the fully attributed entity relationship diagram, you're going to have all of your keys, whether they be primary or foreign keys, will be have to be fully labeled. Your cardinality will be cross-checked. You know many-to-many relationships, things like that. And a big thing is all of your data types have to be specified. And this is where you start restricting yourself to the technology at hand. Say, for example, you're using MySQL, the database management system MySQL. It has a certain set of data types that it uses that are different than Oracle or different than SQL Server. And so if you're going to be using one of those, that comes out over here on the design side, where you're going to have to account for that. Okay, use case diagrams. We definitely have use case diagrams, and you see these leading into interaction diagrams or sequence diagrams. Now, we didn't actually do the sequence diagrams for analysis, and we won't be doing them either, nor did we do state machine diagrams. So on the design side, what we'll be working with here in lieu of state machine and interaction diagrams are what are called data flow diagrams and program flow charts. Those are the two things that we'll be working with in lieu of these. These are more the object-oriented analysis design approach, which I've been kind of shying away from because it's not common to see. I wanted to give you a more standard analysis and design approach that I've seen out in industry. So some changes here. But you might then be asking, okay, if we're doing program flowcharts and I'm sorry, I totally lost my train of thought. Oh, data flow diagrams. You might be asking, okay, well, where does that come from? Because you said everything has to feed into it. Well, if you notice, there's something kind of missing here, which is the sorry. I'm going to have to take care of that. Give me just a minute. Lucky! Come! Come! Bad boy. Sit. It's okay. It's okay. Sit. All right, I'm back. Sorry about that. Let me share my screen again. I think it's this one. Okay. So, one of the other things that you'll be working on are the fully developed use cases. And all of these fully developed use cases, that is what feeds the kind of logic side. Remember, the ERDs are the data side. And so the logic side is going to, on the design side, is going to be built from your fully developed use cases, which would include, moving into the design side, which would include your data flow diagram and your program flowcharts. So beyond the that core component, which by the way are these bottom two here, your database, which is built from your entity relationship diagram, and then the logic, which is built from your user stories and your fully attributed use cases. That's going to be your software classes and methods. Or in our case, since we're not doing object-oriented, we're doing function-oriented, it would be your functions and modules is what you'll be designing. There are three other things to consider, and this is taking a big step away from the perfect technology assumption that we talked about during use cases, where now you have to consider it because you're going to be designing it. You have to think about what type of user interface is going to work well. And you need to have some understanding of HCI, which is a human computer interface. I don't know if anyone is aware. I don't know if anyone is aware. Does anyone know how long humans are okay with waiting? Like if you do something with a computer, say an application, even network-based, when does your patience run out? I don't know if anyone knows that. 6 seconds, that's a good guess. Daniel? Anybody else want to fathom a guess? Yeah. Eric's definitely thinking along the right path. That's correct. It is less. Okay, Haley went too far. Okay, so let me stop you. It is actually 2 seconds. 2 seconds is our point at which we start to wonder, is there something wrong? And I've definitely seen people, generally, again, you don't want to stereotype, but the older the generation, the more likely they are to do this. Once that 2 seconds passes, they're much more likely to start doing stuff, start hitting their keyboard and clicking and doing lots of other things. And to me, that absolutely drives me crazy. I always say, calm down and wait. Anyhow, that's part of the user interface. You need to start thinking about, okay, so based on my understanding, say this 2 second rule, my understanding of this 2 second rule, what if there is a situation where it might run slower? Maybe we should plan to code for a progress bar. Because if the research shows if there's a progress bar, then you're less likely to think there's a problem. That time, assuming that it's correct and moves in the correct way. I don't know if you guys have ever been involved in downloading something and it gets all the way to 99% and then it sits there for hours on end. Even with the progress bar, you're kind of losing your patience because you're like, is something wrong? Should I cancel this? Should I restart it? So as long as it's accurate, it does dramatically increase the amount of time people are willing to wait and are less likely to try to break your system. I've seen situations where people literally will sit on keyboards to try to break the software, and it blows my mind, but it's crazy what people will do. Like the most unexpected thing is what it is that they do. Also, there's the environment itself. This is where you need to start thinking about, okay, is this client server, standalone application? Is there going to be a mobile app perhaps? And this comes down to application components as well. There are all these other pieces that you need to be thinking about other than the core, which are these last two. These last two are the core of the system, which is what does it do? That's this last one. And what does it do it to? That's this second to last one. So that kind of makes sense that that's the core, right? But you still need to think about those other things as well. So we've kind of been through, during the course of the semester, we've been through these first three phases. We're thinking about your initial planning and your logistics and your budgeting and your personnel and your technological requirements and your project approval. Then you moved from that, you moved into gathering the data. You guys did interviews with me and you started to gather the data, and then you start to transform that into the analysis models with some tweaks from me. And now we're moving into this design phase, and you'll see that it's generally around, you really focus a lot on this during the third iteration. And of all of the steps, interestingly enough, this is probably the least impactful. I know that sounds weird. You say, but wait, this is actually creating the blueprint. How could this be the least impactful? I'll go back to my house analogy. If I don't have a good foundation, the whole house is going to fall in on itself. So that's analysis. I have to have a good foundation. And you can see in terms of the size of this hump right here during the second iteration, it's a pretty serious hump. I mean, it's indicating there's a lot of impact and thought and time put into this. Same thing down here. I'm going to skip ahead to implementation. It's very large. There's so much focus during the fourth iteration where you're actually building the system. And if we come back to design, it just isn't quite the same. It's always attached to analysis and attached to implementation. There's always that. It's never going to be like you're going to have an iteration that focuses exclusively on design. You're going to have an iteration that focuses on your planning, for sure. You're going to have an iteration that focuses on your analysis. You're going to have an iteration that kind of does all three. And then one that moves, three being analysis, design, and implementation. And then you're going to have a fourth iteration and a fifth iteration where you're pretty much just building. You might touch back with your systems analyst for a better understanding of some missing piece or something that doesn't make any sense. But 95% of what you do, you being part of this project team, is building during iterations 4 and 5. So to me, it's an interesting concept that it kind of gets lost in the mix. You never really fully focus on design. But it makes sense when you describe it in that way. So these are the previous bullet points where it talked about the key questions for your design. So with the environment, how the system interact with other systems and existing technologies. With application components, the key parts of the information system and how they interact when the system is deployed. Designing the user interface. To most users, the interface is the system. I don't know if you guys have ever get into arguments with your friends about Windows versus Mac, but if you ever do, or let's do something better. Let's say Android versus iPhone. Most of what you probably are arguing about is interface stuff. I don't think anyone's saying, well, the memory management in Android is actually superior because it has a more efficient use. No one's saying that. They're like, man, your icons look stupid. I hate how Android scroll. When you scroll, it just comes with a thud at the top, and it just feels very unnatural. Whereas on my nice iPhone, it kind of has a nice little bounce, so it feels like something real. Or back to the desktop operating system, you might say, I don't like how Macs have the close window button in the upper left. It's doesn't seem natural to me. It should be in the upper right. These are all interface things. It's very rare that users actually think about the superiority of a system based on how well it works, more what it looks like to them. All right, then there's the database. How will the data be captured and structured? This is your ERD and your SQL that you write for this. And then finally, there's the system itself, the internal structure for each application. Yes. So this is you actually writing the code is this last one. So 2 key elements in the environment. First, there's the communication with external systems. You may have required formats for how messages are sent out and communicated with them. Unless you're building an enterprise system, which means it does literally everything, you have to interact with external systems. Let's look at Christopher Newport, for example. You have, off the top of my head, you have a system called Banner, which I believe we just call CNU Live here. You have a system called Blackboard, which we call Scholar here. You have, what was the one? There was another major system that you interact with. But interestingly enough, they actually don't communicate well. Like when I put your final grades in, I have to do that as a separate process outside of Scholar. It doesn't communicate with CNU Live. And it's not the end of the world, but it's something that maybe could have been considered. Yeah, Jacob, it really is. And the really bad part is, this is rare, by the way, don't freak out, but I do make mistakes sometimes. And imagine that if you see your grade in Scholar and it says 94.6, and then you get your grade and it says you have a D. As a student, that's where your heart literally stops for a minute and you're like, I cannot believe this. And then if it's a mistake, it comes out. But certainly human error can come into it when you have a human that's essentially transcribing. Web and networks, there's considering everything is interconnected now, so how is a system going to sit in that? Communications protocols. Generally, we're talking about, that kind of links in with this next point here with security. Protocols are, generally we use a de facto protocol, which is TCP/IP, but that would tie into the security methods, because if it's sensitive data, then you would consider some type of end-to-end encryption for those communications protocols. Error detection and recovery. You might be thinking about outsourcing your data storage, and in case there's some type of flaw in your system, and how do you recover that? How do you even know there was a problem? How, if you have a data integrity issue, how are you going to find it? So, okay, I need to start considering planned audits, where you go in and you audit the data trail. You also need to think about the technology architecture. In other words, what do we have right now? What servers do we have? What type of a local area network do we have? You need to consider how the system will fit into that as well. The application components. This is essentially a unit of software that does something. It does some function, some task. You would need to break this into the so-called modular appropriate sizes. What does it do? Does it do one thing? Does it do it well? What languages are we going to use? And oftentimes there can be an issue with your staff on hand and their expertise. Say your staff on hand are very good with Java and Smalltalk and even Python. Let's say that's your skill set with your staff on hand. And the type of system you need to build isn't going to work well with those, because those are all interpreted language. So interpreted languages means there's no compilation process. And with no compilation process, they run about 10 to 20 times slower than fully compiled systems. So you need to use C++ or some other fully compiled language. So what does that mean now? Now I have a personnel issue. I need to start thinking about hiring people or perhaps training my existing staff. But again, there's time and money associated with that. And then there's this last point, build or buy. You don't want to reinvent the wheel. Can you buy something that will do what you need to do? It's very tempting. And I will tell you that there is a huge danger that organizations face if they choose the buy option. And the danger is, number one, you're trusting some third party now that their code is going to work in an acceptable way. Number two, now there's absolutely no way it's going to be a perfect fit. Let's look at what you guys are doing. You guys are doing a committee management system. There's nothing really out there, but then you start to think, well, there's nothing specifically for committees. However, if I pull up Microsoft Access, as a matter of fact, let's just do that right now. Hold on. I got to share my whole screen here. It always throws me off that it's a separate button. Okay, there we go. Okay, so in Microsoft Access, you see that there are existing templates. And I don't know if guys have ever used Access before, but it's a quasi DBMS. Or if you recall, DBMS stands for Database Management System. So the main ones would be Oracle, SQL Server, DB2, and MySQL would be the main database management systems. Access is only sort of a DBMS because it doesn't allow multi-user access as it stands. There's ways to work around that where you can do it, but as it stands, it doesn't allow multi-user access, which is really at the heart of DBMSs. And number two, Access allows you to set up entities and tables without keys, which violates the core concept of what databases do. That's why I say it's quasi. But let's say, hey, I'll work with that. Let's say you sit down and you say, you know what, I'm going to use the Microsoft scripting, server-side scripting language to work with a centralized Access database so it can be multi-user access. And you know what? Let's see. Education. There's a template. There's a database template for education. We have one for business, whatever the heck that means. Maybe I can work with that. Personal. Let's go with education. It looks like we have project management. We have students. Maybe I can tweak. Faculty. Here we go. So now we're building. Oh, wow. So this is honestly, I've never done the templates before because whenever I have worked with Access, I'm always building raw and complete databases. And with this one, I've noticed that there's only one table. In other words, one entity. So right away, you're running into problems if you're trying to have the shortcut where I could buy a solution. It's like, well, I'm going to have to tweak this. I'm going to have to adjust it. It's not doing exactly what I want it to. And you'll find that even with companies, you may have companies that specialize in creating university software. For example, Banner. Banner and Blackboard is tailored to universities. So, hey, why don't we just buy that? When I worked at the University of Aalto in Finland this summer, they used, have you guys heard of Moodle? I don't know if anyone's heard of Moodle. Moodle is the open source Blackboard. So it's Blackboard that doesn't cost anything, and you have access to the source code, and then they modified it to kind of be customized for Alto University. And to be honest, it was an absolutely terrible experience. I really didn't enjoy working with Moodle. Blackboard is far superior. Bottom line is, buyer beware. You're always going to have a better result if you build it. That's what I'm getting to here. So I've made this point already. To the user interface is the system. Bottom line, that's how important it is. It doesn't mean it is, by the way. Remember, users are idiots. So don't take what they have to say at face value, but it should influence your feeling that you're going to make this easy to use and consistent, and the 2-second rule and all these other things. If users don't accept the system, sometimes that leads to failed systems. The users have to accept it. Great example in the healthcare sector. They did not consider the user interface in the healthcare sector for a lot of the software that runs out there. And there are many, many examples of healthcare organizations or providers that the workers in them did not accept the new system, and they ended up with a lot of turmoil and chaos. Make sure I'm not missing any chats. Yeah, okay. So for the user interface, the analysis will give you information about what the users are hoping to see, which will then move into your design, where you draw out the plans for what you think it will look like. You go back to the users. Notice it says requires heavy user involvement, and say, hey, is this something that makes sense to you? Would you like to use this? You may have people that say, you know what? I don't want to have to click 7 times. It's convenient and it looks pretty, but I would rather have a couple of quick keyboard shortcuts. So you may actually have to have different interfaces depending on the size and needs of your users. So here we see some models that you might build for the design stage of your interfaces, and these are the things you can share with your users. So we see examples here of somebody moving through an interface in order to check out from their purchase. So they go to cart, check out. Now, you might look at this and say, wait a minute. Does this mean that it needs to actually be functional? And the answer is no, because remember, we're just in design right now. These could just be mock-ups, literally something you draw in, say, Google Draw. This is what it'll look like. It'll look like a drop-down menu with a little pop-up that prompts for your email, a confirmation, a shipping, confirmation of shipping, down to your order, and this probably looks like most things. If you guys have bought things online, it probably follows a very similar step to this here. And then you might say, oh, and in this case, they have these multiple user interfaces where we say we also have small screen menu prototype. Clearly, they're referring to like a mobile device that might be using this. Now, I didn't tweak this at all. This is straight from the text, and I'm laughing because I made a big stink earlier on about the fact that nobody really uses domain classes to design data. It's just not something that you do. Almost all data uses relational databases. And the author himself makes that point here. And I say, thank you. Why are we wasting time doing domain classes when we should have been doing ERDs all along, which is what informs the build of a relational database? It says requires converting the data model to a relational database. Perhaps if you had done a domain class step, yes, you'd have to do that conversion. We didn't do that because that's not what happens. You build the ERD from the get-go, make it a fully attributed ERD, and then that informs the build of the database. This is interesting down here that the author brings this up. It says throughput, response time, and security. This is actually not true because DBMSs do this for you. That's the beauty of a DBMS, is that it handles appropriate throughput, appropriate response time, and security is built in to a DBMS if it's configured and used correctly. So I mean, I suppose you should consider it, but it's not additional work that you, the systems analyst or the developer, would have to do. You guys will be seeing a lot of this next semester. Has anyone used PHP MyAdmin? I don't know if anyone has used that. I'm not seeing any nodding heads. Okay, you'll be using it a lot. PHP MyAdmin is kind of the DBA, the database administrator interface for creating your MySQL databases. So you'll be seeing, like in this one here, you see this is for a table called inventory item, which is this one right here. And you see the attributes, which are also called fields, product item, inventory item, size, color, so on and so forth. And then you see the data types right here, like varchar is a variable length character field, medium size integer, more varchars, decimal, dates. So this is the stuff that you would be planning in your fully attributed ERD when you get to the full design where you're actually creating that with your SQL. So some of the last things that you would be considering kind of revolve around security, and me as my main interest is in security. That's actually why I was hired at CNU, was to do help with the cybersecurity program. And then they realized I also specialize in information systems, and they said, oh, we really need you. So I said, cool, I'd like to do that as well. But security is my main interest. And I really like and appreciate that the text goes into a lot of detail, because secure development is something that doesn't happen as much as it should. And it's why we still have so many continued breaches day in, day out, constant security breaches. You think everybody would know about authentication and access control and encryption and all of the things, firewalls, intrusion detection, all of the things that bring up security. That why do we still have these? And it's primarily because there is a lack of security with development, which is what this class is. So this class is a development class for large-scale information systems. It's rare that you see security as part of that. So when they talk about integrity controls, it mentions inputs, outputs, data, and programs. Really, the main thing is data. Was my data changed in an unauthorized way? How do I stop that? What do I do if it happens? What are my recovery options? You need to consider all of these. How do I control my assets from both internal and external threats? Well, there's a whole host of things to do for the external side. These are like your so-called hackers that people think about when you think about security. Internal side is not so easy. That one is a lot more difficult because they're already past the security controls. I don't know if you guys have probably heard of Edward Snowden, the infamous NSA operative. He was inside the NSA when he decided what you guys are doing is wrong, and I'm going to take all of this and I'm going to leave and I'm going to share it with WikiLeaks, and we're going to get it all over that what the US is doing isn't right, to the NSA. So strictly speaking, I'm not going to go into the ethics or the geopolitics of it, but strictly to the NSA, that was a major security breach for them. And it, short of doing constant psychological screening, it's hard to catch. So on the technical side, there are various layers here. Like, we see the firewall in the middle. This controls the flow of network traffic in and out. This probably wouldn't be part of your bill. This would be part of the existing infrastructure 99% of the time. But you still should confirm that and consider it. Processing controls, operating system controls, database controls, your end-to-end encryption, your stored data encryption. Then there's your end devices like desktops and mobile devices and phones, both on the outside and internally within your network. So you have to consider all of these, and usually you'd work with a chief security officer to do that. Um, it says integrated into application programs and DBMS. I don't really like that term or that phrase, because while I mentioned before it is integrated into the DBMS, usually it's not assumed with application programs. With application programs, you need to explicitly include integrity controls into them, because that's where your holes are going to be, and that's where people are going to look for places that they can exploit to get to that DBMS. Sure, appropriate and correct business transactions are accepted. They're recorded and processed correctly, and protect and safeguard assets. Yes, these are all of your objectives for integrity controls. For your input controls, one of the best things you can do is a very common attack is called a buffer overflow attack, where the developer didn't put a limit on how much somebody could enter into a field, and so if somebody put too much stuff, it ended up crashing the system. Or worse yet, they could actually inject code into the field and then take control over the system itself. And there are ways you as a developer can minimize that by limiting the types of things that can go in and the size of the things that can go in as well. It's definitely not something you want to do post facto. You want to do it before it's released, because then the whole system comes into question otherwise. Basic completeness controls, this is just standard if statements where required fields are entered. Data validation, make sure that the data that's entered makes sense. And field combination controls. Now, this one's pretty interesting, because what this is talking about is, we'll go back to the example of like customer and order. You don't want to have an order entered that doesn't have an associated customer, because that could end up causing some problems, where you have these floating orders that aren't tied to anything. So yes, you do want to ensure that the data is, there's an existing customer, but why I'm hesitating with this a little bit is this is not something that you, a developer, necessarily explicitly has to do, because as I said before, the DBMS does have some of these controls built in, and this is one of them. You physically cannot do that in a correctly designed database. In a correctly designed database, it would just kick back an error saying, no, there's no customer. So in the end system, you wouldn't just want an error message to come up. And by the way, I've worked with systems before where it literally just says, some random database error, and I don't even know what to do. Do I hit the backspace on my my browser, or what do I do here? But nonetheless, it's not going to corrupt the system, is what I'm getting at. Make sure that for your output that it's only going to authorized users that can actually see it. Watch for what you do with the data if it's in hard copy. There's something called footprinting, where people actually, they jump into dumpsters to pull out documents in order to help with spear phishing and other forms of attacks. So you should think about processes in place. For example, required shredding, things like that could be a way to protect from dumpster diving. Redundancy, backup, and recovery. Generally, you'd want to consider offsite. The reason being that you can't have a natural disaster which would theoretically destroy everything on site, both hard copy and electronic. So you would want to consider offsite. And then the great debate that organizations are still having, even though it's been literally years, is cloud storage versus proprietary. Because if you do cloud storage, people are nervous about the security of that data itself. I'm trusting this third party to protect my data, or should I have my own site that's out in Nebraska somewhere that I'm backing up regularly? Obviously, one costs a lot more than the other. So then it's a question of cost, and generally cost wins out, where people are just going with cloud storage now for offsite copies. Yeah, Greg, that's the point that I'm making now. Yeah, is that they are, even though it's probably not the ideal scenario, because it is less secure. Um, it's definitely the most cost effective, and that's going to win out in the end. Um, so another thing to consider is fraud prevention. You have to look at, are there going to be situations where people have an opportunity and a motive to, you know, I have to find somewhere else to do these lectures. My dog is driving me absolutely crazy. Um, are they going to have an opportunity and motive to defraud the organization? And it's always there. It's always been around where people look for ways to enrich themselves, disregarding ethics. So something that you need during the design to consider. And the ways you would control for that would be separation of duties, regular auditing of the data, not just monitoring digitally, which is what this is mentioning here, is digital monitoring, but actual visual monitoring as well via cameras. I know that sounds dystopic and not like a fun place to work, but from an organizational perspective, that's how you will minimize fraud, is by doing these types of things. Asset control, and then finally basic security features. Ideally, you would protect all of your assets against external threats for sure. You'd have to do something called a risk analysis to identify those assets, identify the threats, identify the controls, and then identify what you would do in case those things are breached. And considering, uptime 24/7, ideally. Does CNU? No, it's not currently, but there's always the option for special topics, so it might come up in the future. All right, moving on. So basic access controls, you guys will have to do this for your project. You'll have to think about, I don't remember the exact details of every group discussion, but I'm pretty sure I brought up the different levels of access that each of the different groups would have. This is access control. This is where you're thinking about, okay, once a person authenticates themselves, which is this step here via standard username and password, what are they allowed to do when they come in? Are they allowed to see everybody's things? Are they allowed to change the database? Are they allowed to add committees or not? And this is part of this consideration that you'd have. And then we have our various types of users, registered users, systems developers, administrators. Former employees is an interesting one. Generally, the rule of thumb with former employees is cut off. They're done forever. They no longer have access to the system. And I believe that this is implying that because it gives them the same kind of connection as a hacker would, which is this jagged line indicating this is an unauthorized access. Sometimes former employees do maintain access though, so that's why I was not 100% sure on this, but generally they're seen as a threat now as opposed to a viable access. Data encryption. You always want to encrypt sent data. This is something that you should plan on, whether it be through digital certificates or basic encryption algorithms. You should always encrypt sent data. Stored data, it depends. There are a lot of processing cycles that go into encrypting stored data, and to the point where it wouldn't be cost effective to increase your processing power to handle all of that, and unnecessary as well. But with all of that said, you really need to store sensitive data like passwords, credit card numbers, things like that. You should encrypt, but as little as possible. Secure transactions. So this is SSL, secure socket layer, and transport layer security. These are basic encryption protocols that you can use for sent data. All right.